Today we're going to take a look at working with radicals section 5.1. As you can see from the diagram, a radical includes an index which will let you know what root you're looking for. It includes a radicand, which is the number under the bracket, and the bracket is called a radical sign. And the whole thing is called a radical. Now radicals can be rational numbers, so example the square root of 4, because the square root of 4 is equal to 2, and 2 is a rational number. And it can also be an irrational number like the square root of 2, which when you work it out on your calculator will give you 1.41 with some numbers following it. And so you can see that it is a non-repeating, non-terminating decimal. Now, if there is no index specified, then it's understood to be a square root. Radicals always mean to take the positive value. So to illustrate that, I've got 3 scenarios here. So the first one is you're asked to solve for y in y squared equals 25. Now, to solve for y here, you want to take the square root of both sides. And remember, when you do this, because they're not specifying whether you want a positive or a negative square root, you need to indicate both. So you go plus and minus square root 25. And so y is equal to plus and minus 5, and you get 2 answers. In the second scenario, we've got that the square root of 25 is equal to 5. And we know that because our radical is positive. It's understood to be positive square root of 25, and so when we take the positive square root of 25, we get 5. And our third scenario is negative square root 25, which really means negative 1 times the square root of 25, which will give you negative 1 times 5, and so your answer is negative 5. Okay, so when you have a negative sign in front of the radical, it will give you a negative answer. Okay, like radicals, what do we mean by that? We mean that they will have the same radicand and the same index. It's important that we know that they're like, because we can only combine like radicals, not unlike radicals. So very much the same as when you're combining algebraic expressions. You can only combine like terms. So if you take a look at the chart, you've got 2 columns. The first column gives you pairs of radicals. The first pair, we know that they are like because they both have a 2 as an index. Remember, if it's not indicated, it's understood to be a 2. And both of their radicands are 7. On the second example, our indexes are both 3, and our radicands are both 5x squared. Now in our second column, we have examples of unlike radicals. So why are the first 2 radicals not like? Well, if you take a look, even though they share the same index, 2, they don't share the same radicand. So these are unlike because they have unlike radicands. The second pair of numbers are unlike because if you take a look at it, one of them has an index of 4 and the other one has an index of 5. Even though both of their radicands are the same, their indexes are not. So it's not like, so we say they're unlike because they have unlike indexes. Okay, another topic that we need to take a look at before we start working with them are restrictions on variables. Now, the only time that a restriction happens is when you have an even numbered index, and because you have an even number index, you can't have a negative number. In other words, your radicand must be non-negative, and what we mean by non-negative is that it can be equal to 0 or greater than 0. So when we put these 2 together, that means whatever the radicand is, it has to be greater than or equal to 0. So why is that? Well, the reason, if we want to, for example, take the square root of negative 25, we know that that can't be 5 or negative 5, because if I square a 5, I get 25, which is positive, and if I square a negative 5, I get a positive 25 also. And notice in both of those cases, we don't get a negative 25. In other words, there are no two numbers that when I multiply them together, there are no two same numbers that when I multiply them together will give me negative 25. The only way to get negative 25 is to go 5 times negative 5. Okay, another example. Let's say you want the fourth root of negative 16. Okay, well that can't be equal to 2 or negative 2, right? Because even though 2 to the fourth power gives me 16, that's not a negative, and negative 2 to the fourth power gives me a positive 16 too. So in both of those cases, my 16 is not negative. In other words, there are no four numbers that are the same that when I multiply them together will give me a negative 16. Okay, so whatever my radicand is, it has to be greater than and equal to 0. So let's take a look at this example. Our radical is 4 minus x. It has an even index. We know that because it's a 2. So 4 minus x must be greater than or equal to 0. Okay, so that means the radicand, or if you like, the argument, needs to be greater than or equal to 0. So let's find out what values of x are acceptable, and that will make 4 minus x a positive number. So we're going to take the 4 minus x, make it greater than or equal to 0, and we're going to isolate the variable, which means to solve, and in this case for x, we're going to add x to both sides. So on the left, these ones will cancel out, so we're going to have 4. 0 plus x is x, so we get 4 is greater than or equal to x. Generally, we put the x first, number second, so we're going to take our inequality and we're going to reverse it, put the x first, the 4 second. When we do that, the sign has to switch from greater than and equal to less than and equal to. Okay, so what does this tell us? Well, this tells us that whatever value x is, it has to be less than 4 or equal to 4. It can't be greater than. So let's see if this works. Let's take a look at when x is greater than, when x is less than 4. I'm going to choose where x is equal to 0. I'm going to substitute that in. I'm going to go 4 minus 0, and that gives me square root of 4, which gives me a 2, so that works. I want to see what happens to my radical when x is equal to 4. So x is equal to 4. I'm going to plug that in. I'm going to get 4 minus 4, which gives me 0. The square root is 0, and the square root of 0 is 0, so that works. I can do that. The last scenario is what happens when x is greater than 4. So I'm going to choose where x equals 5. I'm going to substitute that in, so 4 minus 5, that gives me square root of negative 1. And I can't work out the square root of negative 1. It is undefined. And so this doesn't work. So this is the end of part 1 of this video.